Hello everybody. So today what we are going to be doing is we're going to be looking at the background information that we need to graph linear equations. And the first one goes way back to the beginning of the year, and that is, how do you know if something is a solution? The only difference that we're doing this time is what we're checking for when we're looking at a solution is a coordinate instead of just one single number. So let's check if these points are solutions to this equation. And the first thing that I'm going to do is I'm going to figure out what variables 1 and 2 are. Now, since in a point we start with x and then we write y, we are going to end up with x is equal to 1, y equals 2. So when we're doing this tells us what we're going to substitute in. And remember that if this is a solution, it makes this statement, x plus 2y equals 5, true. So if x is 1, I can write 1 instead of x. And if y is 2, I can write 2 instead of y. Now 1 plus 2 times 2 is in fact equal to 5, because 2 times 2 is 4, and add that 1 according to order of operations, and that gives us 5. So since 5 is equal to 5, I know that the point 1, 2 is a solution. Let's check out 7, negative 3. Again, start with labeling your x and your y. You can do that just by dropping a coordinate right over top. And that means that x equals 7, y equals negative 3. Fill in your equation, x, or 7, plus 2 times our y value of negative 3 is equal to 5. Now what this is going to give us is, well, we have to start with multiplication first. So 2 times negative 3 is negative 6. Add that 7. And is that equal to 5? Well, no, that's equal to 1. So since 1 is not equal to 5, it means that 7, negative 3 is not a solution. Now the reason why this is important is because what we're going to be looking at is a series of solutions to a specific equation. So let's say that you're looking at a graph. And your graph is like this. Now this graph is actually of the equation x plus 2y equals 5. And we're going to see how to make the line that represents the equation in a little bit. But what this line is actually telling us is what points I could put in to this equation. So it's all of the connecting x and y values. And I can use this graph to tell me that. So for instance, if I went to 1 over for my x, I know that y would have to be 2 because that's the point that fits on the line. And that's why 1, 2 works as well with our solution, because I know that it's on the line. In fact, I could zoom in and there are an infinite number of points in any of these little sections that form this line. So you can almost think of this line as just a series of points, not as like this almost continuous thing. It's just those points get so infinitely small that we can't even see the distance between them. So you could find a whole bunch of other things that would work in this equation. For instance, if I wanted to know what y would be when x is 3, I can just look and it should be 3, 1. In fact, go ahead and check, is 3, 1 a solution? And you can put that right on the note sheet next to the other two that we checked. So check that real quick. Is 3, 1 a solution to x plus 2y equals 5? Because it should be. Just show me the work. Now you can also see points here that would not be solutions. For instance, our 7, negative 3, while it is a point on the graph, is actually nowhere near our line. So that means that this, since it's not on the line, is not a solution. So with a graph, you can easily see all the solutions to an equation. All right, so now that you've checked 3, 1 as a solution, I would like you to find out if the following are solutions to a different linear equation, 2x plus y is equal to 1. So do 1, 2, and 3. Pause the video, finish them up, and then we'll continue on in just a moment. All right, so now that you've finished those, and you should have whether or not they're solutions, and I'll show you that one tomorrow, we are going to be looking at function form or slope-intercept form. And this is actually something that we do quite frequently when we're doing equations. We like our equations to look like y equals mx plus b, and you guys are going to see why. But for now, let's practice that skill of rewriting equations so that they're in that slope-intercept form. And we can do that by solving for y, or getting y by itself. So I'm going to do that right here. This should look very similar to what you guys were doing. I want to move everything away from the y. So the first thing that I'm going to do is I'm going to get rid of addition and subtraction, because when I'm solving, I work backwards through order of operations. So that gives me this. Now, notice how the x term comes first when we have y equals mx plus b. So that means when I'm writing this right side of the equation, I want my 2x to be in the front. And then I can add on that 8 afterwards. Notice that the sign in front of the 2x stays with the 2x, and since 8 is positive, that's a plus sign there. On the other side, I've canceled out my 2x, but I still have 4y. Now I want y by itself. So what I'm going to do is I'm going to cancel out the multiplication by dividing by 4. Now don't forget, on the other side, you must divide the entire other side by 4. And since you have that little plus sign making life complicated, you've got to do the heart. And so that leaves us with y is equal, well, 2x over 4 is the same as 2 over 4x, which is 1/2 x. And it is best that you keep this as a fraction. Just don't forget that if you have a fraction like 2/4, you simplify that down. Maybe you do that along the side. It's up to you. Now I also have here an addition, and I know it's an addition because I can see that plus sign, and there's no negative here, of 8 divided by 4. And 8 divided by 4 is 2. So that means my final equation is y equals 1/2 x plus 2. And I have rewritten my formula. Now remember that negative signs are going to be a big deal, so be very careful. Watch your negatives and go ahead and do 2 and 3. The last thing that we're going to do is we're going to learn how to check if you did this right, and we're also going to gather information for what we're going to do tomorrow. Now, here's how you can check. You know that x and y have certain points that work and certain points that don't, just like what we had been doing above with the 1, 2, and the 7, -3. You know some points will work in the equation and some points won't. Now, because all you did was switch the order around, anything that works in this, any x, y that works in this, should also work in what you wrote. So what we're going to do is we're going to find a few points that work in the first, and I'm just going to double check that they work in the second. And to keep everything organized, because we're going to use the same information in a moment, so not only am I checking that I rewrote it right, I'm actually gathering information for our next step of graphing. And in order to do this, I'm going to put what I call a T-chart. And at the top, I have my left x values, and on the top right, I have my y values. And what I'm going to do is I'm just going to say, okay, if x is equal to, let's say, 0, what will y have to be? So I take my equation, the one that I rewrote, and I say, okay, what is y when x is 0? So I go ahead and I fill that out, and I mean, you might have been able to almost do that in your head, but remember, showing your work is really good, and it slows you down and it catches those little mistakes that throw us off. So 1/2 times 0 is 0, and 0 plus 2 is equal to 2. So that means that since this whole thing is equal to 2, that means that y is equal to 2. So when x is 0, you get a y value of 2. Now, if that's true here, it must also be true in this original equation, because remember, we have just rewritten the equation. So I'm going to check, and if it does not work, if 0, 2 is not a solution to this, don't forget that there are 2 places you could have made a mistake. You could make a mistake when you are checking your solutions, or you could have made a mistake by switching the formula. So don't be afraid to give it a few checks if something seems to be wrong. But let's go ahead and try that out. we've got 4 times y minus 2 times x is equal to 8. My y value is 2. Careful that you're substituting into the y here. And my x value, of course, according to my t-chart, should be 0. So 4 times 2 in this check is giving me a value of 8, of course. And 2 times 0 is 0. And is it true that 8 minus 0 equals 8? Why, yes, it is. So that means that we did this right, and this is a solution to this or our rewrite of it. Okay, now, I want to find a few more solutions to this equation. So I'm going to do that. And mind you, this is describing a line. So that means that all kinds of points are going to work for this. And I can pick any points that I want. And really, I just like to pick a various x values that I think will be easy to work with in order to do this. So, for instance, I might pick 1. I might do a -1 just for fun. Or, well, why not just do 2 as well? And generally, we like to find at least 3 points. So I'm going to find each of these one at a time. So I want to know, what will y be when x is 1? And I'm going to use my rewrite because it's a little bit easier than this one. This one I have to solve and get things by itself. This one I'm just plugging in a number. So when I have my y equals 1/2 x plus 2, I'm going to substitute in the x value that I want, which is, in this case, 1/2, or I'm sorry, 1. And I'm going to solve. So 1/2 times 1 is just 1/2. And if I add 2 to that, I get an answer of 2.5 or 2.5. And on the other side, of course, I just have y. So that means that y is equal to 2.5. And I can fill that into my chart. So again, I'm seeing what happens when x is equal to that. Now, I don't need to check this one again because generally, if you have one point that works in both, it's highly unlikely that you solved it wrong. But I still want to do this with one more point, so I'm going to do it with one more point, and I'm going to find out what is y when x is 2. So just like before, I'm going to put in my x value of 2, and I'm going to see what y equals. Well, 1/2 times 2 is just 1. 1 plus 2 is 3. Therefore, in this case, y is equal to 3. And therefore, I have 3 points in an xy chart that satisfy this equation. So that leaves your turn. You guys have 2 and 3 to rewrite. Put them as a y equals something. Once you have that done, I want you to make a t-chart with 3 different values on it. That means for this problem, I need to see the rewrite. So that looks like y equals. I need you to find xy in a t-chart. And I want you to do that 3 times. So you're finding 3 points in that t-chart. And for one of those points, probably that first one, check if your answer to 1 is correct. If you are not sure, this is what I did right above, so rewatch that video and double check. Now I want you to do this for 2 and for 3. So by tomorrow, that means I should see one more solution checked for the very first problem. For those next 3, I should see that you checked those 3. And for these ones, I should see them rewritten, those t-charts filled out, and of course, I should see the work for you checking that you rewrote the equation correctly. Now, if you try 3 times and your equation is still not right, you can put it on the back burner and check it tomorrow. But I need to see that you checked it 3 times, so don't just erase all that work. Have it on a fresh piece of paper when you try again. I hope you guys are having a wonderful day. I will talk to y'all tomorrow.